Hello students, welcome to my class. In this video we are going to be discussing about center of mass of the discrete particle system and the center of mass of the continuous mass distribution. Let us see the first question. The first question says the distance between the centers of carbon and oxygen is given, and here it is 1.13 into 10 power minus 10 meter is given. The distance of center of mass of the molecule relative to the carbon atom they are asking. Here two atoms is given, one is carbon atom it's given, and here one more it's given as oxygen atom it's given. Carbon mass, here its atomic weight, here it will be 12, and oxygen you can take as 16 you can take, and these two are separated by distance is given. Here it is given as it's a 1.13 into 10 power minus 10 meter it's given, and this is a carbon mass you have to take. Now they are asking center of mass from the carbon atom they are asking. Let us take here a center of mass. You can take an assumption it will be located at this point. Let us take this is R1 you are taking, and here it will be R2 suppose you are taking. Here M is inversely proportional to the R will be getting. With that, here we will be getting as where the mass will be heavier, their location of center of mass will be nearer will be getting. Where the mass will be lower, and here distance of location of the center of mass will be far away will be getting. So here you can take with this here we will be getting one relation, that is from the carbon atom in the sense we will be getting as R1 which will be equal to, you can take as M2 into D by, you can write it as M1 plus M2, M1 plus M2 you can take. Then R1 which will be equal to M2 in the sense here this mass of the oxygen you can take, that is 16 into here you can take as D in the sense it's 1.13 into 10 power minus 10 meter by, you can take as M1 plus M2, that is 12 plus 16 you can take. Now here we will be getting a R1 which will be equal to, so 16 into, if you are multiplying this value here this is 16 into 1.13 into here 10 power minus 10 by, here you can take as this 28 you can take, and here you can take as 4 4s 4 7s will be getting, and 4 you just multiply, here will be getting as 4.52 into 10 power minus 10 by, here will be getting as 7 will be getting, and when you are calculating this value here will be getting as, so 0.64 into this value 10 power minus 10 meter you are getting. So this is the correct answer. Let us see the next question. The next question says if the distance between the centers of the atoms of potassium and as well as bromine is given, and in a potassium bromide molecule is 0.282 into 10 power minus 9 meters is given, the center of mass of this two particle system from the potassium they are asking. Here one potassium is given, and here one bromine is given. Here this is a potassium you can take, and this is a bromine it's given, and here its mass is given, mass of the bromine is given as 80 units is given, and here mass of the bromine, so mass of the potassium is given as, here it is 39 units, mass of the bromine is given as 80 units is given, and these two are separated by distance is given as 0.282 into 10 power minus 9 meter it's given. Now here we would like to calculate the center of mass of this two particle system from the potassium. Let us take here, this is the center of mass of the location, you can take an assumption, this is at R1 distance you can take, and here the other particle it will be at R2 distance you can take, and here you will be getting the relation will be R1 which will be equal to M2 into D by, here you can take as M1 plus M2 you can take, which is nothing but here M2 in the sense here bromine mass you can take, that is 80 unit into D is given as 0.282 into 10 power minus 9 is given by, you can take as 39u plus this is 80u. You will be getting, when you are simplifying this one, R1 value, distance of location of center of mass from the potassium molecule, you will be getting as potassium atom, you will be getting as nearly 18.9 into 10 power minus 9 you will be getting. In fact, when you are calculating and you just multiply and divide this value 10 power minus 2 by 10 power minus 2, and here this is initially you are getting like this 0.189 you will be getting, and here R1 value, when you are doing here you just multiply and divide this value, then you will be getting as 18.9 into 10 power minus 9. 10 power minus 2 you can take, 10 power minus 9 you can write it as nanometer you can take. So here 18.9 into 10 power minus 2 nanometer is the correct answer. Let us see the next question. The next question says, in a molecule of sodium chloride, so the masses of sodium and chlorine is given as they are in the ratio of 23:36. If the separation between the two atoms is given as d, the distance of center of mass of the molecules from the sodium atom they are asking. So here it's given as sodium chloride it's given, and here you can take as this is Na, and here you can take as this is Cl you can take. This masses ratio is given as 23:36. Now here they are asking d is the distance of center of mass of these two, distance between these two molecules we can take. Now here let us take an assumption. Here the center of mass will be located at this point, and this is about the distance r1 you can take, and here it is about the distance r2 you can take. From the sodium atom they are asking, let us take here r1 equals to, here you can get it as m2 into d by, you will be getting as m1 plus m2 you can write, then r1 which will be equal to, so here mass of the second one is given as, here m1 by m2 ratios is given as 23:36 is given. Let us take m2 value will be 36 times mass you can take into d you can take by, here m1 plus m2 in the sense, here you can take as 23m plus 36m you can write, which is nothing but here 36m into d by, here you can get it as 59 times of m will be getting, mm gets cancelled. So nearly r1 value will be getting as 36d by, here will be getting as 59 you are getting. 36d by 59 is the correct answer. Let us see the next question. The next question says, two bodies of masses is given as 10 kg and 20 kg are located in xy plane at 0, 1 and 1, 0 it's given. The position of center of mass they are asking. It's going to be lying, two bodies of masses is given, which is lying on the xy plane it's given. So this is an xy plane you can take, and here two bodies, one mass is given as 10 kg, 10 kg is located at 0, 1. So here this is 10 kg mass you can take, this is here you will be getting as it's located at 0, 1. So along x-axis it will be 0, along y-axis at 1 meter distance you can take, and here the second mass it is given as 1, 0, which is 20 kg mass it's given, and here it will be located at 1, 0. It's lying on x-axis, so y value will be 0. It's lying on y-axis, so that x value you can take it as 0. Now here we would like to calculate the position of their center of masses they are asking. So position of center of mass for a two particle system you can take as, so let us take here it is lying in the plane, so xcm which will be equal to, you can write it as m1 x1 plus m2 x2 by, you can write it as m1 plus m2 you can take. That's nothing but here m1 into mass, here let us take this is x1 y1, and this will be here you can take as x2 y2 you can take. m1 is 10 kg you can take into x1 value will be 0 plus m2 will be 10 kg, 20 kg, it's lying on 1 meter distance by m1 plus m2 will be 30. So together when you are simplifying it will be gets cancelled, 20 by 30, that an XCM value here will be getting as 2 by 3 will be getting. In the same way here you just calculate the YCM also. YCM which will be equal to, you can write it as M1 Y1 plus M2 Y2 by, you can write it as M1 plus M2 you can take. M1 is given as 10 into Y1 value will be located at 1 meter plus M2 is 20 into 1 0 you can take by here total mass will be 30 you can take. This will get cancelled, 10 by 30 in the sense here will be getting as 1 by 3 will be getting. So here the position of that center of mass in the sense here you can take as along x-axis and y-axis you are talking in the sense which will be lying at 2 by 3 comma 1 by 3 meters distance. This is the correct answer. Let us see the next question. The next question says here 3 particles of masses is given 1 kg, 2 kg and 2 kg are placed at the corners of an equilateral triangle is given. The coordinates of ABC is given. Here 1 kg, 2 kg and 2 kg are placed at the corners of an equilateral triangle. Here it's given as one equilateral triangle it's given. Right here you can take ABC it's given. This is here you can take as A, and here this is you can take as B you can take, and this is about the C point you can take. So here at the A point here you are placing 1 kg mass, and here at the B you are keeping as 2 kg mass, and at the C you are keeping as 2 kg mass you are going to be keeping. The coordinates of ABC is given as 0, 0, and here it will be given as 2, 0 it's given, and here some error is given students, here not x, y, and obviously C will be located, C x, y, the coordinates of that center of mass they are asking. Let us take here the C value, it's an equilateral triangle is given, means here on side length value clearly it is indicating as 2, 0 means here each side you can take as 2 meters, this is 2 meters, and here also you can take as 2 meters. So C coordinates when you are talking this sense, here you can take this is the bisector you can take. Now here this is 2 meter distance, means here from A to B 2 meter distance, means this distance will be 1 meter will be getting, that means point C along x-axis here it will be located at 1 meter distance, and here this is a triangle you are taking the sense, here this is a hypotenuse will be getting, and this is the side will be getting, the another side you can take as side square which will be equal hypotenuse square minus side square you can take, 2 2s are 4 minus 1 will be getting, and side value will be getting as root 3 will be getting. So this side value will be getting as root 3 meters will be getting along y-axis. So C coordinates will be getting as 1, root 3 you can take. Now let us take an assumption here that this is x1, y1, and here you can take this is x2, y2, and this will be you can take as x3, y3 you can take. Now just take the center of coordinates of the center of mass. Let us take here XCM which will be equal to M1 x1 plus M2 x2 plus M3 x3 by, here you can take as M1 plus M2 plus M3 you can take. When you are substituting this value, here it is 1 kg into 0 plus, so 2 into 2 plus, here you can take as 2 into 1 you can take, by here we will be getting as total mass will be 1 plus 2 plus 2, here we will be getting as 5 kg, so together we will be getting as 6 by 5 will be getting. Let us take in the same scenario YCM when you are talking M1 Y1 plus M2 Y2 plus, here you can take as M3 Y3 by, here you can take as M1 plus M2 plus M3 you can take, which is nothing but here you can take as 1 into 0 plus 2 into 0 plus 2 into here you can take as root 3 you can take. All the y1, y2, y3 values you have to substitute students, by total mass will be 5. Together when you are simplifying this one, here it will get cancelled, here will be getting as 2 root 3 by 5 you are getting. So 6 by 5 and 2 root 3 by 5 is the correct answer coordinates. Let us see the next question. The next question says center of mass of Two particles with the masses is given as 2 kg, 1 kg are located at 1, 0, 1 and 2, 2, 0 as the coordinates is given. So here it's a two particle system, students, but it's lying in XYZ plane. It's means here it's going to be it's lying in the space. You can take here that coordinates is given as 1, 0, 1 it's given, and here the other coordinates is given as 2, 2, 0 it's given. Let us take an assumption. This is x1, y1, z1 you can take, and this will be x2, y2, z2 you can take. And here for a two particle system, the coordinates when you are talking xcm when you are taking, which will be equal to, you can take as m1 x1 plus m2 x2 by, you can take as m1 plus m2 you can take, which is nothing but here you can take as m1 in this sense. Here it's a 2 kg is given, so 2 into 1 plus m2 is given as 1 kg is given, m1 is 2 kg and m2 is given as 1 kg, 1 into, so m2 x2 value will be getting as 2 will be getting by, here you can take as m1 plus m2, so 2 plus 1 will be getting as 3 will be getting, so together will be getting as 4 by 3 will be getting. So this is an xcm value. Let us take in the same way ycm value also just calculate m1 y1 plus m2 y2 by, you can take as m1 plus m2. m1 is given as 2, here y1 is given as 0 plus m2 is given as 1 kg, and here y2 you can take as 2 you can take by, total mass will be 3, so together you can take as 2 by 3. And here ZCM when you are talking here m1 z1 plus m2 z2 by, here you can take as m1 plus m2 you can take, which is nothing but here you can get it as 2 into 1 plus 1 into 0 you can take by 3 you can take, which is nothing but here will be getting as 2 by 3 will be getting. So the coordinates will be 4 by 3, 2 by 3 and 2 by 3. This is the correct answer. Let us see the next question. The next question says particles of masses 100 and 300 grams having position vectors is given as 2i cap plus 5j cap plus 13k cap and minus 6i cap plus 4j cap plus 2k cap. Position vector of their center of mass they are asking. So position vector of center of mass, the formula will be getting as right, r center of mass, that is nothing but m1 into first position vector plus m2 into, you can take as r2 by, you can take as m1 plus m2 you can take. That means here you have to simplify this one. Here 100 grams is given, r1 position vector is given, this is r1 you can take and this is r2 you can take. Just you have to put the value, this is 2i cap plus 5j cap plus 13k cap plus m2 it's given as here 300 it's given into, here you can take as minus 6i cap plus 4j cap plus 2k cap by, here you can get it as m1 plus m2 it's given, m1 plus m2 value 100 plus 300 you can take as 400 you can take. Then RCM which will be equal to, here you can take as, this is 100 into 200 minus 300 into 6, 1800 will be getting, 1800 minus this 200 will be getting as minus 1600 will be getting. So here you can take as minus 1600 I cap plus, so 200 into 500 plus 1200 will be getting as 1700 will be getting, 1700 J cap plus all the J caps you have to take and K caps you can take, 100 into 1300 plus 600, so together will be getting as 1900 K cap will be getting by 400 you can take. Here numerator and denominator 2 zeros you have to eliminate, so together will be getting as a position vector of center of mass will be minus 16 by 4 into I cap plus 17 by 4 into J cap plus 19 by 4 into K cap will be getting. This is the correct answer. Let us see the next question. Particles of masses is given as 1 kg and 3 kg or at 2i cap plus 3j cap plus 13k cap it's given, and here another one is given as minus 6i plus 4j minus 2k, then instantaneous position of the center of mass they are asking. The same model question, students. Here RCM, which will be equal to, you can take this is the position vector R1 you can consider, and this is R2 bar you have to consider. M1 R1 plus, here you can get it as M2 R2 by, here you can get it as M1 plus M2 you can take, which is nothing but M1 is given as 1 kg, and here its position vector is given as, this is R1 you can take, and let us take that this is R2, right? Here it is given as 2i cap plus 5j cap plus 13k cap. M2 is given as 3 kg, and here it will be minus 6i cap plus 4j cap plus minus 2k cap it's given. By here you can get it as M1 plus M2, 1 plus 3 will be getting as 4 will be getting. Then here you have to simplify this one, students. Here I cap when you are taking common, this is 2 minus 3 6 are 18 into I cap plus, and the next j cap when you are taking this side 5 plus 12 into j cap you can take plus, and here you can take as 13 minus, here you can take as 6 into k cap you can take. By here we will be getting as 4 will be getting. So here you can take as, this is 2 minus 18 which will be equal to minus 16 I cap plus 17 j cap plus, here you can get it as 7 k cap by 4 will be getting. So minus 16 I cap plus 17 j cap plus 7 k cap by 4. So this is the correct answer. Let us see the next question. The next question says here, masses of each 1 kg are placed at the vertices of an isosceles triangle ABC, in which AC equal to BC, which is given as 5 cm, and AB is given as 8 cm. So the distance of center of mass of the system from the vertex they are asking. Here this is an isosceles triangle it's given, students. And here let us take here, this is A point you can take, and this is a B point you can take, and this will be the C point you can take. And here AC is 5 cm, and BC also it will be 5 cm is given. AB value is given as 8 cm it's given. Total it's given as 8 cm it's given. The distance of center of mass of the system from the vertex C they are asking. Now just look at the students. Here look at this student. Here a mass of each one is given as 1 kg. This is also 1 kg, and this is also it's given as 1 kg. Now if you are looking at A and B, both will be having the same masses, 1 kg and 1 kg, and their center of mass where it will be located in the sense here at exactly at the center will be getting. Because masses will be same, so that their center of mass will be exactly at the center, that is 4 cm distance here it will be located. Now here we need to calculate the distance of center of mass of the system from the vertex C they are asking. From the vertex C in the sense here, and again now here we will be having one more mass, this is C mass, and this is your origin you can take. From this C point here we need to calculate the center of mass. And here it's given as this is 5 and this will be 4 in the sense here obviously this one will be getting as 3 centimeters will be getting. Now let us take here, I'm just taking an assumption, this is the C point you can take. From the C point, and here one more point you just take, this is a, let us take that, this is the D point you can take, and this is the D point you can take. It's located at 3 centimeter distance you can take, at 3 centimeter distance. Let us take here, these two are separated by distance 3 centimeters. Somewhere the location of center of mass will be present. Let us take R1 you can take, and this will be R2 you can take. So mass of the C value will be 1 kg, and here you just look at student, this whole mass in the sense here you can take as, this is total mass will be 2 kg will be getting. That means D mass now will be getting as 2 kg, not the 1 kg, and here it will be 2 kg. So 1 kg and 1 kg, 2 kg whole center of mass will be, it's located at the D point. So here instead of D, at the point D, I am just taking as 2 kg. Now just substitute these values. Here I would like to calculate R1 value from the vertex C they are asking. So from the C point, in the sense R1, which will be equal to, the formula will be M2 into D by M1 plus M2 will be getting. Here M2 value you can take as 2 you can take, and D in the sense here it will be located at 3 cm by total mass will be now C. C will be 1 kg and D will be 2 kg. Total together will be 3. So 3 gets cancelled. So that answer will be getting as 2 cm will be the correct answer. Let us see the next question. The next question says here, 4 particles, it's given as P, Q and R and S of the masses is given as 1 kg, 2 kg, 3 kg and 4 kg are placed at the corners of the square. Of side is given as 1 meter as shown. The coordinates of the center of mass of the system they are asking. Now here it's given as one square system is given, students. The square it's given, and here it's going to be located at along x-axis you can take, and here it will be along the y-axis you can take. Now here it's given as this is a P point it's given, and this is a Q point is given, and R point is given, and S point is given. Corners of square of side is given as 1 meter, students. Here each side is given as 1 meter. Now first you need to identify the coordinates, students. And here point P you are taken the sense here it will be at the origin you can take 0, 0, and this is at 1 meter distance, means point Q will be coordinates will be 1 and here it will be 0 you can take. And here when you are talking about the R value, here along x-axis here it is 1 meter, along y-axis also here it will be 1 meter distance here it is located. So that R coordinates you can take as 1, 1. Yes, when you are talking, S will be located on y-axis, so that x coordinate will be 0 and y coordinate you can take as 1 you can take. Now let us calculate its square is lying in a plane, so you must talk about the 2 coordinates, that is one along the x-axis and y-axis. So for a 4 particle system, position of center of mass will be M1 x1 plus M2 x2 plus, here you can get it as M3 x3 plus M4 x4 by, you can write it as M1 plus M2 plus M3 plus M4 you can take, which is nothing but here you can take all the masses. First kg it's given as, this is 1 kg mass is given P, and Q is given as 2 kg mass, and here R is given as 3 kg mass, and here it is given as 4 kg mass it's given. This is a 4 kg mass. Now I just put the values here, we will be getting as 1 into 0 plus 2 into 1 plus 3 into 1 is the 3 into 1 you can take, plus here we will be getting as 4 into 0 you can take by total mass. Total mass value nearly will be getting as 10 will be getting. So when you are simplifying this one, 1 into 0 will be 0, and here 4 into 0 will be 0. 2 1s are 2, and here 3 into 1 will be 3 will be getting, 2 plus 3 will be 5, 5 by 10. So here we will be getting as 1 by 2. That's nothing but 0.5 meters will be getting, 0.5 meters. In the same way, YCM also you have to calculate, students. YCM, when I am just talking here, M1 Y1 plus, here you can take as M2 Y2 plus M3 Y3 plus M4 Y4 by, you can take as M1 plus M2 plus M3 plus M4 you can take, which is nothing but when you are putting these values, YCM value here you can get it as, it's a 1 into 0 plus 2 into 0 plus 3 into 1 will be getting, plus 4 into 1 will be getting, by total mass will be 10 kg you can take. This will get cancelled, 3 plus 4 will be 7. So here it is 7 by 10, which is nothing but 0.7 meters will be getting. So XCM value it will be 0.5, YCM value will be 0.7 meters. This is the correct answer. Let us see the next question. Next question says here, 4 particles is given, each of mass is given as 1 kg, are placed at the corners of a square of OABC it's given, of side is given as 1 meter. it is at the origin of the coordinate system. O is the origin of the coordinate system is given. Now here you can take one 4 particles is given. Here you can place like this. So here they are located at OA, BC it's given, and here it's lying in plane you can take, it's along x-axis, and here it will be along the y-axis you can take, and here O, and here OA and OC are aligned at along the positive x-axis. This is OA you can take, and this is OC you can take, and obviously here this is B point you can take. All the masses is given as, here it is given as 1 kg like that, and here also it's given as 1 kilogram, and here it is 1 kg you can take, and here also you can take as 1 kg. Now here the position vector of their center of mass there also means here it's a square is given of each side is given as 1 meter students, 1 meter it's given. Now here let us talk about center of mass of the system. Now here suppose here you are taken as in terms of position vector, suppose if I am talking position vector, if I am talking, so here RCM, when you are taking RCM, which will be equal to, here you can take as M1 into, directly you can take x1 I cap plus y1 j cap plus M2 into x2 I cap plus y2 j cap you can take plus M3 into, you can take as x3 I cap plus y3 j cap you can take, plus here you can take as M4 into x4 I cap plus y4 j cap you can take, by total mass you can take, total mass will be 4 you can take. Then you just put the values here, all the values here. RCM when you are taking, here M1 is 1 kg, x1 y1 value you can take as 0 plus 0 you can take, this is 0 plus 0 into 0 plus 0, x1 I cap plus y1 j cap you can get. This is here you can take as this coordinates you can take as 0 comma 0, and here this coordinates you can take as 1 comma 0, and this coordinates when you are talking, here it is 1 comma 1, it's lying on x-axis will be 1 meter, along y-axis here it will be 1 meter, and here you can take as this is 0 comma 1 you can take. Now just put all these values here, you will be getting as M2 in this is mass 1 you can take, x2 value it is 1 I cap, so 1 into I cap you can take, plus 0 into j cap will be getting, plus M3 in this sense here you can take as 1 kg, x3 value 1 into I cap plus 1 into j cap you can take, plus M4 you are taking 1 into, along x-axis will be 0, plus here you can take as j cap you can take, 1 into j will be j, by you can take as 4 you can take. When you are simplifying, this one gets cancelled, 1 I cap plus 1 I cap, 2 I cap will be getting, this is 2 I cap plus 1 j cap plus j cap, here will be getting as 2 j cap will be getting by 4. So when you are taking 2 common, here will be getting as I plus j cap by 2 will be getting. So this is the correct answer. Let us see the next question, students. The mass of the uniform ladder of length is given as 5 meter is 20 kg. So on a uniform ladder it's given. This is a uniform ladder it's given. And here you just look at, students, here uniform ladder of length is given as 5 meter. This total length of the ladder is given as 5 meter, and its mass mass is given as 20 kg. So here uniform ladder, it seems like a regular body. For regular body, center of mass will be located at the center. So here the center of mass of the ladder, where it will be located in the sense nearly at a 2.5 meter distance, here it will be located. Now here the next, a person of mass 60 kg stands on the ladder at a height of 2 meters. So here the person will be here, he is at a height of 2 meters. So this is here, you can take as midpoint, you can take as right, this is 2.5, you can take 2.5, and the person will be located here at a 2 meter distance from the ground. It's given position of the mass from the bottom, and here the position of center of mass of the ladder and the man from the bottom nearly. So from the bottom you need to calculate, students. So now you can take here, this is an origin you are taking, here you can take. So here is a man will be there, this is a man will be there, and here is at a 20 meters distance, and here this is a ladder center of mass, here it will be located at 2.5 meters distance, here it will be located. Now we would like to calculate from the bottom, this is our origin. So now I just put the values here, it's all lying along the y-axis. So here I am just talking about coordinates along the y-axis. So YCM, which you can write it as m1 y1 plus m2 y2 by, you can write it as m1 plus m2. So m1 mass is given as, mass of the ladder is given as 20 kilogram and into y1. So it's a position of center of mass will be at a 2.5 meter distance. m2 will be 60 kg, he is at a 2 meter distance is given. Here it's a non-distributed, non-uniform body. So you can take its distance, you can take from the bottom 60 into 2 by, you can take as m1 plus m2. 20 plus 60 you can take, which is nothing but 8 you will be getting. Directly I am taking, and here this value will be getting as when you are substituting m1 y1 plus m2 y2 by m1 plus m2. Here and 0 if you are eliminating in both numerator and denominator, 2.25, it is 5 plus 6 2 is 12 by, here will be getting as 8 will be getting, together will be getting as 17 by 8, which is nothing but here will be getting as 2.125 meters will be getting. So 2.125 meter is the correct answer. Let us see the next question. The next question says here, the coordinates of center of mass of the particles of the masses is given as 10, 20 and 30 grams, are at right center of masses it's given as 1 centimeter. The position coordinates of mass 40 grams, which when added to the system, the position of the combined center of mass at 0, 0, 0 they are asking. Let us take the first scenario for a 3 particle system. So here you can write it as XCM. How we can write? This is m1 x1 plus m2 x2 plus m3 x3 by, here you can write as m1 plus m2 plus m3 you can take. Here already this coordinates of center of mass is given, along x-axis will be 1 centimeter is given, which will be equal to, so here this is 10 into x1 plus second mass will be 20 into x2 plus 30 into, you can write as x3 by, it is m1 plus m2 plus m3, 20 this is 30 plus 30 will be getting as together 60 will be getting. So that doesn't mean 10x1 plus 20x2 plus 30x3 value will be getting as 60 centimeter, 60. Now let us see the second scenario. The position coordinates of the mass for 40 grams, which when added to the system, the position of the combined center of the mass is there also. So here the position coordinates, by adding what you can get the, again the center of mass will be at 0, 0, 0 will be located. That's a question they're asking. Now let us take here XCM dash. If I am talking here, it will be here fourth particle after adding, you can write it as m1 x1 plus m2 x2 plus m3 x3 plus, here you can write it as m4 x4 by, here you can get it as m1 plus m2 plus m3 plus, here you can get it as m4 will be getting. So now the new position of center of mass will be 0, it's given. So here you can get as 0, which will be equal to m1 x1 plus m2 x2 plus m3 x3. Together this whole value we know already, that is 60 plus m4. In the sense here you are going to be adding the 40 grams mass. So 40 into x4 by, you can get it as, so this is here 30 plus 30 60, 60 plus 40 will be getting as 100 will be getting, which is nothing but here you can take as 60. When you are 100 into 0 will be 0, so here 60 which will be equal to minus 40 into x4 you can take. This 10 gets cancelled, 2 3s 2 2s will be getting. So here x4 value will be getting as minus 3 by 2 will be getting. In the same way, when you are calculating here YCM, ZCM, when you are taking here Y4, like you can take as similarly Y4 equal to minus 3 by 2 will be getting, Z4 also will be getting as minus 3 by 2 will be getting. So minus 3 by 2, minus 3 by 2 and minus 3 by 2 is the correct answer. Let us see the next question. Masses of 1 kg, 1.5 kg, 2 kg and m kg are situated at, their coordinates is given. If their center of mass is situated at 1, 1, 3 by 2, then the value of m they are asking. This is for a 4 particle system, students. So here you can take XCM. When I am talking XCM value, here this is here m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by total mass. In the sense here you can take as m1 plus m2 plus m3 plus m4 you can take, students. Let us take here, these are all the coordinates. Here you can take as 2, 1, 1 it's given, and here 1, 2, 1, 2, minus 2, 1 is given, and here it is minus 1, 4, 3 is given. Like you can take as this is x1, y1, z1, like x2, y2, z2, like this is here x3, y3, z3 you can take, and here it will be x4, y4, z4, like that you just take assumption. Let us take here this coordinates also is given. If their center of mass is at 1, 1, 3 by 2. Already the center of mass will be located at 1 is given, 1 centimeter. Now here we just calculate the final mass value. M1 in the sense here will be getting as 1 kg. So it's a 1 into 2 plus, and here you can take it as 1.5 into you can take it as 1 you can take plus, this is 2 into 2 you can take plus, here you can take it as m into you can take it as minus 1 you can take, right? x4 value will be getting as minus 1 it's given, and here final mass will be m is given. By total mass you can take it as m1 plus m2 plus m3. So 1.5 plus 1 2 plus 1 will be 3 and it's a 4.5 plus the next mass will be m. Now just simplify this one here by doing cross multiplication. Here what you can add here, this is 1 into 2 will be 2 plus 3.5 2 plus 1.5 3.5 3.5 plus 4 7.5. So here we will be getting as in numerator will be getting a 7.5 minus m will be getting by 4.5 plus m you can take, it is 1 you can take. Now we just cross multiply this one. Here this is 4.5 plus m, which will be equal to 7.5 minus m will be getting. Together you can take as this is 2m you can take by bringing this side. 7.5 minus 4.5 will be getting as 3 will be getting, then mass value will be getting as 3 by 2, which will be equal to 1.5 kg you are getting. Like in the same way YCM also you are taking and ZCM also you are taking, the same mass will be getting, students. If you want you can try, that is 1.5 kg is the correct answer. Now let us see the next question. The coordinates of center of mass of the system as shown in the figure it's given. Coordinates they are asking, students. Here let us take here you can take as x equal to at 0 distance, and second mass is given as L, and here this is 3m is given at x equal to L. and here one more another mass is given as m. It's lying on y-axis at a distance L is given. So first you have to take the coordinate, students. Here x value, here it will be 0, 0 you can take. This is here, let us take it as x1, y1 you can take. And here next you can talk about x2, what is second particle you can take. It's going to be lying at x equal to L. So here you can take it as x2, y2, which is nothing but here you can take it as L, 0. And here next you can take here x3, y3 you can take, which will be equal to, here you can get it as this is going to be lying, and third mass here it will be, here it is going to be located at 2L distance. So here you can take as 2L, 0 you can take, and x4, y4 you can take. It's going to be lying at, this is here along x-axis. Along x-axis here it will be L distance, and here along y-axis here it will be L distance. So here you can take as L, L. Now let us talk about the XCM and YCM values. So XCM, when I am talking here, this is m1 x1. So here you can take as m into 0 plus, and m2 x2. Second mass will be m into x2 value, here what is given here, L you can take. L you can take plus third mass it's given as 3m you can take, and here its x coordinate will be at 2L distance plus. So here fourth mass is given as m is given, and here it's it is along x-axis. Here along x-axis here it will be located at L distance. By here you can take as m1 plus m2 plus m3 you can take. Together total you will be getting as 3 plus 1, 4, 5, 6 will be getting. So 6m. So this will get cancelled. Here when you are simplifying this one, here will be getting as, this is nearly 3 2s are 6, 6 plus 2, 8 will be getting, that is 8 ml by, here will be getting as 6m, mm gets cancelled, 2 4s are 2 3s are will be getting 4 by 3. So here will be getting as 4 by 3L, which will be equivalent to, here you can take as 1.33L you can take. This will be the XCM value. Next let us discuss about the YCM also. YCM which will be equal to m1 y1. M in the sense here you can take as m, y1 value will be 0 plus m into y2 value it will be 0. Third mass is given as 3m, and its coordinate is given as 2L, 0 it's given. So here you can take as 0 plus, here you can take as m into, here its coordinate will be L will be getting. So here by you will be getting a 6m will be getting. So here these are all gets cancelled. Here mm gets cancelled. Here will be getting as L by 6 will be getting. So L by 6 value here will be getting as nearly 0.167 L will be getting. So the correct answer is 1.33L and 0.167L is the correct answer. Let us see the next question, students. Here one end of the thin uniform rod of length is given as L and mass m1 is riveted to the center of uniform circular disc of radius r is given, and mass m2, so that both are in coplanar. So here one circular disc is given, students, and here a thin uniform rod you are going to be placing. This is a thin uniform rod you are going to be placing, which is riveted. A thin uniform rod of length L, its length is given as L is given, students, and here and mass m1 is given. M1 is riveted to the center. At the center you are going to be fixing of uniform circular disc of radius is given as, this radius is given as r is given. Now here we would like to calculate, and mass of the disc also it's given as m2 it's given. So here the center of mass of the combination from the center of the disc is, so from the center of the disc they are asking, students, here this is your origin. So about this origin here we would like to calculate the center of mass. You know, for this uniform rod, in the sense here the center of mass here it will be located at L by 2 distance here it will be located. Why? Because this is a uniform rod, L by 2 distance, right? And this is your origin you can take, this is 0, 0 you can take. Now XCM, when I am talking in this sense here XCM, so here this is here what you can take here, this is XCM. When I am talking here, it's going to be lying only along the x-axis, not along the y-axis. XCM, when I am talking in this sense here, this mass will be m1 into this position of center of mass will be L by 2 distance you can take by, here you can get it as m1 plus m2 will be getting, total mass will be m1 plus m2. That's nothing but XCM, which will be equal to, here you can take as m1 into here L by 2 into here you can take as m1 plus m2 you can take. So here this is the correct answer. So no body is lying along the y-axis, you are not supposed to talk about the YCM values. So this is the correct answer, because the rod also is going to be lying along the x-axis. Let us take the next question. A uniform bar of mass is given as 8 meter long, has a mass of 6 kg. A 10 kg mass is given, is tied to one end. The position of center of mass of the system is. So here a uniform bar is given, students. This is a uniform bar it's given, and here it's given as 8 meter long it's given. And together here it will be 8 meter long it's given. And here a 10 kg mass you are going to be tying like this. This is a mass here you are going to be tying. This mass is given as m2, let us take here this is 10 kg. And here a rod mass is given as 6 kg it's given. It is 6 kg. Now position of center of mass of the system they are asking, students. Here let us take this is the uniform rod you can take, the center of mass where it will be located in the sense here exactly at the center. So here it will be center of mass will be located, and here you can take one mass, here you can take a 6 kg mass, 6 kg mass, center of mass will be here you can take, this is about the 6 kg mass you can take. One more mass here you have to consider as a particle, this is m2 it's given as, here it will be 10 kg, and this is m1 you can take as 6 kg you can take, students. Now I would like to calculate the position of center of mass, you just calculate, and here you can take, these are separated by distance will be getting as 4 meters. So here to here will be 4 meters, and here to here also will be getting as 4 meters, and this total distance will be getting as 4 meters separation distance. Let us take here an assumption, here the center of mass will be located somewhere in between those 2 points. Let us take the center of mass, and now here you can take this is R1 you can take, and let us take this is R2 you can take. Now here you can get it as R1, which is nothing but here you can get as m2 into d by, you can get it as m1 plus m2 you can get. M2 in the sense here mass will be getting as 10 kg, 10 into d will be 4 by m1 plus m2. M1 plus m2 in the sense 6 plus 10 will be getting as 16 will be getting. So here will be getting as 4 times. So here will be getting as R1 value will be getting as 2.5 meters. So that means here from 10 kg mass, R1 in the sense here will be getting as 2.5 meters from the 6 kg mass, and from mass m2 in the sense here it will be lying at, total distance will be 4 meters. So here from 10 kg mass it is at 1.5 meter distance you can take from 10 kg mass. Let us take the next question, students. The next question says a ball of mass is given 3m rolls from the rest on a smooth flat table towards another ball it's given of mass is given as 2m. 2m mass is given, which is at rest is given, and with a constant velocity 5 meters per second. When the two balls are separated by a distance of 6 meters, the position of center of mass from the mass 3m they are asking. Now here you can take, students, here a ball of mass 3 kg is given. So this is a 3 kg mass, 3m is the mass you can take, which is moving with the 5 meters per second velocity you can take, students, and it's moving with the constant velocity. And the second ball it's given as 2m, which is at rest is given. When the two balls are separated by distance 6 meters, the position of center of mass from the mass is the 3m they are asking. So just there for confusing they have given, students, here one is at rest and one is at the it's moving the velocity they are asking. Here the position of center of mass, in the sense here you can take, this is here one particle you have to consider, this is 3m mass, and here it will be 2m mass you can take, and these two are separated by distance you can take as 6 meters, 6 meter distance here you can calculate, and this is the center of mass between the two you can take an assumption, this is 3m and this will be the 2m, right? So this is, let us take R1 and this will be R2 you can take. Now here you can take as from 3m they are asking, from 3m in the sense here you can take as R1, which will be equal to, it's an m2 into d by, you can write it as m1 plus m2. So m2 in the sense here will be getting as 2m will be getting, into d value you can take as 6 you can take, by here you can write it as m1 plus m2. m1 plus m2 in the sense 2m plus 3m will be getting as 5m will be getting, mm gets cancelled, 2 6 0 will be getting as 12, it's 12 by 5 you can get, and here 12 by 5 in the sense here will be getting as 2.4 meters will be getting. So this is the correct answer. Let us take the next question, student. 3 particles of masses is given as 1 kg, 2 kg and 3 kg are placed at the vertices of A, B and as well as C of an equilateral triangle is given of ABC, and here it's one equilateral triangle it's given. And here you can take, so ABC, if A and B are lying at, this is an A you can take, and here it's going to be lying at 0, 0, and here B is going to be lying at 1, 0, and here it's going to be lying as C, it's going to be lying as here this coordinates you can take, students, now. So here it's an equilateral triangle it's given in this sense, here this is at 1 meter distance you can take, here AB distance you know, with that we can calculate, this is also 1 meter distance, and here also it's a 1 meter distance you can take. Now you can take here C coordinates when you are talking, here this x coordinate values here will be getting as, along x axis here it will be located at 1 by 2, along y axis when you are talking, here you can take a side square you can take, side square which will be equal to hypotenuse square minus side square you can take, which is 1 minus here 1 by 4 you can take, that is 3 by 4 will be getting. Then another side will be getting as root 3 by 2 will be getting. Along y axis here it will be root 3 by 2. So now the coordinates will be along x axis 1 by 2, along y axis will be 3 by 2. So you can take 1 by 2 and root 3 by 2 are the coordinates for the C mass you can take. So now here it's a mass it's given as 1 kg, and here B mass is given as 2 kg, and here C mass is given as 3 kg it's given. Now the coordinates of that center of mass you can take, students. xm1 which will be equal to, that is m1 x1 plus m2 x2 plus m3 x3 by, here will be getting as m1 plus m2 plus m3 you can take, which will be m1 in the sense here mass is given as 1 kg, and here it will be at 0, plus m2 is given as 2 into here x2 in the sense here will be getting as 1, and here m3 you can take as 3 kg and x3 value will be getting as 1 by 2. By total mass here you can take as 1 plus 2 will be getting as 3, 3 plus 3 will be getting as 6 will be getting. So just simplify this one, students. 2 plus 3 by 2 by 6 you can take. 2 to the 4 plus 3 7, 7 by 2 by 6, 7 by 12 will be getting. And this is XCM, students. In the same way YCM also just calculate. YCM value here you can take the formula. So let us take here, you can take YCM, which will be equal to M1 Y1 plus M2 Y2 plus M3 Y3 by, here we will be getting as M1 plus M2 plus M3 you can take. So M1 value here it is given as 1 into Y1 value it is given as 0 plus M2 value you can take as 2 kg and here it will be at 0 plus here you can take as 3 into, here you can take as root 3 by 2 is the Y coordinate by, here you can take as 6 you can take, which is nothing but here we will be getting as 3 into root 3 by 2, 6 are 12 will be getting. So 3 4 times, so here we will be getting as root 3 by 4 will be getting. So here XCM and YCM values here will be getting as, which will be equivalent to 7 by 12 and root 3 by 4. 7 by 12 and root 3 by 4 is the correct answer. Let us see the next question, students. Here 3 particles, each of mass is given as 1 kg mass, are placed at the corners of a right angle triangle. It's given AOB. O being the origin of the coordinate system. It's on right angle triangle it's given, students. Yes. This is one right angle triangle it's given, students. Here 3 particles will be located and here OB is the origin it's given. OA will be along positive x-axis OA and OB is given as along the positive y direction it's given. So this is y-axis you can take and this will be along the x-axis you can take. So here this is OA and OB is given. So along the positive x-axis and along the positive y-axis is given. If OA equal to, here it is given as 1 meter, OB it's given as, here it is given as 1 meter, the position vector of this center of mass they are asking. Let us take first these coordinates, students. Here you will be getting as right here it's given as, here 3 particles of mass is given as 1 kg. This is, here you can take as 1 kg mass and here also it's a 1 kg mass you can take, and here this is also 1 kg mass, and here this coordinates when you are talking, here you can take as 0, 0. A it's given as, here it is it's 1 meter means 1, 0 you can take. So B coordinates you can take, it's going to be lying at 0, 1 meter distance you can take. Now the position vector of that center of mass they are asking. Now here along x-axis and y-axis position vectors they are asking, students. Here you can calculate first XCM value, just calculate. That's nothing but here M1 x1 plus M2 x2 plus, here you can take as M3 x3 by, here we'll be getting as m1 plus m2 plus m3 you can take. So here m1 value here we'll be getting as m1 here it's given as 1 kg. Here it's a 1 into x1 will be getting as 0 plus m2 will be getting as 1 kg it's given. x2 value here you can take as 1 you can take, plus here m3 it's given as 1 kg, and here x3 value will be getting as 0 by here you can take as m1 plus m2 plus m3, this is 3 you can take, which is nothing but here will be getting as 1 by 3 will be getting. So in the same way here YCM you can talk. YCM when you are talking here you will be getting as y1 plus here you can take as m1 y1 plus m2 y2 plus here you can take as m3 y3 you can take, by you will be getting as m1 plus m2 plus here you can take as m3 you can take. And now here you have to substitute students all these values, and here we will be getting as m1 value here will be getting as 1 into y1 value will be 0 plus m2 value will be 1 into y2 value will be getting as this is 0 plus m3 value will be 1 into 1 by here you can take as total mass will be 3 you can take, which is nothing but 1 by 3 you can take. So here this is all about the XCM and YCM values. Position vectors they are asking students. Position vectors when you are talking the sense here RCM when you are talking RCM which will be equal to xi cap plus here you can take as yj cap you can take. That means position vector along the x-axis here where it is located here 1 by 3, it's a 1 by 3 I cap plus here you can take as 1 by 3 j cap you can take. So I cap plus j cap by 3 you can take. This is the correct answer. Now let us take the next students. Here you will be getting as 4 particles of masses is given, and here it's a 2 kg, 2 kg and has as well as 4, 4 like that it's given, are arranged at the corners of ABCD of a square. It's given as ABCD, of side is given as 2 meter, and the perpendicular distance of their center of mass from the side AB they are asking. And first you need to take the coordinate students. Here it's given as already 0, 0 and 2, 0, and here it's given as 2, 2, and here let us take here this is x1 y1 you can take, and here it will be x2 y2 you can take, and here it will be this is x3 y3 you can take, and here it will be x4 y4 you can take. Now here let us talk about here XCM and YCM values. XCM when you are talking here, so XCM which will be equal to here we will be getting as m1 x1 plus m2 x2 plus here m3 x3 plus here we will be getting as m4 x4 you can get m4 x4 by here we will be getting as m1 plus m2 plus here you can take as m3 plus m4 you can take, and here you just substitute the values. So when you are substituting the values here we will be getting as x1 y1 values, here I just substitute students. Here you will be getting as m1 is here 2 into 0, that is 0 will be getting, directly I am writing, plus 2 into here will be getting as 2 plus, so 4 into 2 will be getting plus 0 will be getting m4 and y4 x4 value by here you can take as total mass will be 12 you can take, 2 plus 2 4 plus 4 will be 8, 8 plus 4 will be getting as 12 will be getting. So 4 2s are 8, 8 plus 4 will be getting as 12, 12 by 12 will be getting, which is nothing but here will be getting as 1 will be getting. In the same way YCM when you are talking YCM value which will be equal to m1 y1 plus m2 y2 plus here you can take as m3 y3 plus m4 y4 by here we will be writing as m1 plus m2 plus m3 plus m4 will be getting, which is nothing but here you can take as 0 plus 2 into 0 plus and this is 4 into 2 you can take plus and 4 into 2 you can take. By here we will be getting as total mass will be 12, and which is nothing but here we will be getting as 0 and 4 2s are 8, 8 plus 8 will be getting as 16, 16 by 12 we will be getting 4 4s are 4 3s are we will be getting, which is nothing but 4 by 3, which is nothing but 1.33 will be getting. So it's a 1.33. So here they are asking the perpendicular distance of their center of mass from the side AB. From the side AB in the sense here only perpendicular distance in the sense here you must talk about along the y-axis alone, students, so that you can take as 1.33 is the correct answer. So you need not talk about the XCM values, only along the y-axis you can talk, so you will be getting the result. Let us take the next question, students. Here are 3 identical spheres, each of radius r are placed touching each other so that their centers A, B, C lie in the straight line. The position of their center of mass from the A they are asking. And here 3 identical spheres is given. This is one sphere is given and one more sphere also is given, and here all the 3 will be touching each other. Right. So here let us take this is A you can take, and this is B you can take, and this is C you can take, students. Here all the 3 will be lying on a straight line. We need to calculate the position of their center of mass from the A they are asking. This is your origin, students, and here each radius is given as r is given. This is r, and here to here we can take as r you can take. Each radius is given as r is given. This is also r it's given, and here also it's given as r. Now here when you are taking here all are identical masses you can take, students. All are identical, they are lying in the x-axis in the sense here you can talk about the xcm, which will be equal to you can take as m1 x1 plus m2 x2 plus here you can take as m3 x3 by here will be getting as m1 plus m2 plus here you can take as m3 you can take, which is nothing but here you can take as xcm value m1 in the sense here you can take as m you can take, x1 in the sense from the origin in the sense here so this location of center of mass will be at the origin, so that here you can take as x1 value will be 0. You are calculating from the center of mass of the A particle, so that if the origin is if the center of mass is coincide with the origin, then you can take it value will be 0. So m2, let us take it as m you can take x2 value, this center of mass where it will be located at 2r distance, and the next we connect as m, and here this center of mass of the 3 at what distance here it is located means here to here r 2r 3r, and here it will be 4r will be getting. So together you can take as 4r by here you can take as total mass will be 3m you can take. So here it will get cancelled, 4 plus will be getting as 6, so here we can write it as 6mr by 3m will be getting. So 3 2s are, so here we will be getting as 2r will be getting. So 2r is the correct answer. Let us take the next question, students. Here are 3 identical spheres, each of radius 3 cm are placed on a horizontal surface touching one another at square. So they are placing on a horizontal surface, they are touching one another, and here the distance of center of mass of the system from any center of the sphere they are asking. And here it's given, students, here are 3 spheres, they are touching each other, it's given. This is one more sphere you can take, and here you can take as one more sphere here. So that all the three will be touching each other, it's given. And here the distance of center of mass of the system from any one of the center of the sphere they're asking. So here you can take, students. So all the centers, when you are going to be combining, here it forms like an equilateral triangle, right? So here the distance of center of mass of the system from any center of the sphere they're asking. So center of mass for all the three particles, here it will be located at the centroid, you can take, students. So here centroid at what distance, in the sense here it will be, so here this will be at a by root 3 distance, and here it will be a by root 3 distance, and here it will be a by root 3 distance, here it will be located. And here you can take, and the distance of center of mass when you are taking, here you can take as, so this radius, suppose you are taking as a, you are taking, students, here you can take as a by root 3 distance. This is the location of center of mass. Now a value how much will be getting in this sense, this is here you can take as 3 centimeter plus 3 centimeter. Together side you will be getting as 6 centimeters will be getting. So all the three sides you will be getting as 6 centimeters. Here to here it will be 3, and here to here we will be getting as 3. Together we will be getting as 6 centimeters. So each side you will be getting as 6 will be getting. So here you can take as 6 by root 3 you can take, students, and which will be is nothing but here we will be getting as 2 into 3. So 3 I am writing as root 3 into root 3 by root 3 you can take. And here we will be getting as distance of location of center of mass will be getting as 2 root 3 centimeters you are getting. Now let us see the next question, students. The next question says here the particles of masses is given as m, 2m, 3m, and so on. Nm is given. Grams are placed on the same line at the distances. Here it is given as L, 2L, 3L, and so on. NL is given centimeter from the fixed point. The distance of center of mass of the particles from the fixed point in the centimeters they are asking. And here you can take, so these are all the n number of the particles are located, and here you can take one particle mass is given as m is given, and here this is a mass m, and here it is will be located at L distance, and second mass is given as 2m is given, and here it will be located at 2L distance is given, and the third mass is given as 3m, and here it will be located at 3L distance from the origin. Like here n number of the particles will be present, and here this is nm you can take, and here it will be located at nm distance you can take. So here this is the fixed point you can take. From the fixed points they are asking the location of center of mass. All the particles they are lying along the x-axis, so here you can calculate the center of mass along the x-axis alone. So here you can write m1 x1 plus m2 x2 plus m3 x3 plus and so on. Here we will be getting as mn xn you can take by, here you can write it as m1 plus m2 plus m3 plus and so on. Here you can write it as mn you can take, students. So here when you are simplifying this one, m1 value, m is given as m you can take. Here x1 initial at L distance, here second mass is given as 2m, and it is about distance you can take as 2L, and a 3m mass is given which is at 3L distance plus and so on. Here we will be getting as mn nm, and here it is located at nl distance you can take. This is nl distance by total mass you can take as m plus 2m plus 3m plus and so on. Here we will be getting as nm will be getting. Now here in the numerator you can take here L if you are taking common, students. ml you can take common. ml when you are taking, here you can write it as, so this is nothing but 1 square you can take, 2 into 2 you can take as 2 square plus next one will be getting as 3 into 3 will be getting as 3 square plus and so on n square will be getting by, which is here m if you are taking common here in denominator, 1 plus 2 plus 3 plus and so on, here will be getting as n will be getting. So mm gets cancelled, so here will be getting as xm, which will be equal to sum of the squares will be getting as L into n plus 1 into 2n plus 1 by 6 will be getting, into here will be getting as sum of the natural numbers will be getting as n into n plus 1 by 2 will be getting. By 2 you just bring into the numerator. So n into n plus 1, n into n plus 1 gets cancelled, 2 3 times it is going. So here you can take as 2n plus 1 by 3 into you can take as L you can take. So this is the correct answer. Let us take the next question, students. Here 4 particles of masses is given, m, 2m, 3m and 4m is given, are arranged at the corners of a parallelogram with each side equal to a is given, and one of the angle between the two adjacent sides is given as 60 degrees. Now the parallelogram is lying in xy plane with its mass is given as m at the origin and 4m on the x-axis. The center of mass of the arrangement will be located at. So it's lying in xy plane, it's given, students. Here you can take one parallelogram, you can take. This is here, you can take one parallelogram, you can take, students. Right here you can take, it's lying on xy plane, you can take, students. It's lying along y-axis, and here x-axis you can take, students. 4 particles of masses m, 2m and 3m or 4m. So here you can take as m you can take, and this will be 2m. xy plane, the mass m is at the origin and 4m is lying on the x-axis. And here this is the 4m mass you can take, it's lying on the x-axis. So whatever it may be, here you can take as 3m you can take as an assumption, and here you can take as 2m is an assumption you can take. And here parallelogram side equal to a is given. This is the side is given as a is given. Now here you just look at, students, here the side which is adjacent side, here it's making an angle 60 degrees is given, and here you can take it's making an angle 60 degrees it's given. So here a, it is 60 degrees in the sense, here this side component will be getting as a cos 60, a cos 60 you can take, and here this will be a sin 60 you can take, which is nothing but here will be getting as a into sin 60 value will be getting as root 3 by 2, and here it will be a cos 60 in the sense, here will be getting as a by 2. So here this mass will be located at, here you can take with the different colors, this is 0 comma 0, and here to here the distance we are calculated as a by 2. So here you can take, right, here it is 60 degrees in the sense, here also you can take, this is making an angle 60 degrees, and here you can take, this is total distance when you are talking, here to here it will be a, each side is given as a, and this a value will be getting as a cos 60, it's nothing but a by 2 will be getting. So here this is 4m coordinates you can take as, it's lying on x-axis at what distance in the sense, here you can take as, so here a comma 0 you can take, and here 3m coordinates when you are talking, here along y-axis, so this distance here will be getting as a plus a by 2, a plus a by 2 will be getting as 3a by 2. This is along x-axis. Along y-axis we are talking this is here. This is a sin 60 will be getting. A sin 60 is nothing but a into root 3 by 2 will be getting. So this is root 3a by 2 will be getting. Now here let us talk about the 2m mass along x-axis. Along x-axis here it will be located at a by 2 distance. Along y-axis here it's a y-axis in the sense here you can take as a into root 3 by 2. So these are the coordinates you are getting, students. Here let us take clearly this mass m coordinates you are take as. Mass m coordinates will be here it is 0, 0 and here 4m mass, here the coordinates will be this is a, 0 and here the next thing is here 3m mass coordinates will be 3a by 2 comma root 3a by 2 you can take, and 2m coordinates you can take as a by 2 comma root 3a by 2 is given. Now let us calculate the center of mass. So in a plane in the sense here you can take as xcm and ycm you can talk, students. Xcm which will be equal to so m1 x1 plus m2 x2 plus m3 x3 plus here we will be getting as m4 x4 by here you can take as m1 plus m2 plus m3 plus m4 you can take. We just put all the values here, the value will be getting as 0.95 will be getting, 95a will be getting, and here ycm when you are talking here you can take as m1 y1 plus m2 y2 plus m3 y3 plus m4 y4 by you can take as m1 plus m2 plus m3 plus m4 you can take, students. So if you want in detail here you can take as here this is x1 y1 you can take, and this is x2 y2 you can take, and this is x3 y3 you can take, and here it will be x4 y4 you can take. And when you are substituting all these values here will be getting as nearly it's a root 3 by 4 a will be getting. So 0.95a and root 3 by 4a is the correct answer. So now let us see the next question, students. So 3 identical particles is given, and here their mass is each of mass is given as are placed touching each other with their centers on a straight line. So centers they are going to be lying on a straight line. Their centers A, B, C respectively. The distance of center of mass of the system they are asking. Let us take this, students. Here are 3 identical particles, each of mass. Like this is here, you just imagine this is one particle, and here this is one particle you can take, and this is one more particle you can take. Let us give the name as this is A, B, C, and here the distance of center of mass of the system from the system A. So this is the center of mass of the A you can take, students. Here right. So here they are lying xy plane. Here you can take xcm when I am talking the distance of center of mass of the system from A. From A, 3 particles you can take, students, or else. This is the A particle, and here this will be the B particle, and this will be the C particle you can take, and here we need to calculate from the A particle, and here it's lying on x-axis when you are talking xcm equal to m1 x1 plus m2 x2 plus here you can take as m3 x3 by here you can take as m1 plus m2 plus m3 you can take. So all are identical, it's given. Masses you can take as same. Here m into here A about A point in the sense here its center of mass will be coincided exactly at the A point. So here you can take as x, it will be 0. M2 you can take as m you can take. Here x2 in the sense here will be getting as AB is the distance AB plus here m into x3 in the sense here we will be getting as A to C distance will be getting AC by here you can take as m1 plus m2 plus m3, which is nothing but 3m you can take. That means xcm when you are taking here it will get cancelled, So in numerator m you have to cancel. Here we will be getting as AB plus AC by, here we will be getting as 3 will be getting. It's an AB plus AC by 3 is the correct answer. Let us see the next question, students. Here are 3 identical spheres. Each of radius is given as r or placed on a horizontal surface touching one another. If one of the sphere is removed, the shift of center of mass they are asking. So let us take here 3 spheres is given, students. All are touching each other. Now let us take here, this is third sphere you can take. Here one more sphere you can take. This is a one more sphere you can take, and all the 3 is touching one to each other. We are placing like this on horizontal surface, and here if one of the sphere is removed, now let us take here their centers, how they are aligning in the sense. Their centers, they are forming like an equilateral triangle you can take, students. And this is, let us take that this is A sphere and this is the B sphere and C sphere you can take, students. Here A will be located at 0, 0 you can take. B will be located, let us take here this radius I am taking as r you are taking, and here to here is r, and here to here you can take as 2r you can take. So here we will be getting as 2r, 0. And here C particle, when I am talking C, here this center of mass, here it will be at r, and here you are taking as here this point, here you are talking, when I am talking about this distance, y distance, here this is r you can take, x coordinate will be r will be getting, and here y coordinate will be, it will be root 3r will be getting. This is root 3r will be getting. Since here you can take this side, here will be getting as r plus r, 2r will be getting, right? So here side square, in the sense here you can take as hypotenuse square minus side square you can take. Hypotenuse square will be 2r whole square means 4r square minus r square you are getting. That's nothing but 3r square will be getting. So here side, which is nothing but root 3r will be getting. So root 3r. So A coordinates will be getting as 0, 0, and B coordinates will be getting as 2r, 0, and C coordinates you are getting as r, root 3r you are getting. Now here if one mass you are removing in the sense, so first let us calculate here. Before removing, you can calculate the XCM value. XCM, when I am talking about center of mass along x-axis, here m into here x coordinates, here this is x1, y1, like x2, y2, like this is here you can take as x2, y2, and here it will be x3, y3, like that you just take, and here m into 0 will be getting plus the next m into here will be getting as 0 along m2, x2, sorry, m into 2r will be getting plus the next mass m into here will be getting as r will be getting by total mass will be getting as 3m will be getting. So which is nothing but here m into 2r plus m into r, here will be getting as 3mr will be getting, 3mr by 3m will be getting. Here 3m gets cancelled, here it will be r will be getting. In the same way here YCM, when I am talking here, this is m into 0, m1 y1 plus m2 into y2 plus m3 into here you can take as y3 you can take, that's nothing but root 3r by here you can take as 3m you can take, and here this will gets cancelled, here mm gets cancelled, root 3 by 3 in the sense here will be getting as r by root 3 will be getting. So before removing here RCM values, so RCM values here what you can get, RCM values here will be getting as 1 will be at x coordinate will be r, and y coordinate of center of mass will be r by root 3 will be getting. Now here final center of mass, when you are talking after removing, final center of mass if I am talking. So after removal of that one, here we will be getting as only two things will be getting. One here it will be, and second one will be like that we will be getting. And here if you are calculating the center of mass when you are talking, here it's lying only on the x-axis. So here you can take about this mass here you are calculating means. So RCM value here XCM when you are talking, here XCM will be M1 X1, it will be 0. So to this one after removal of that one, so here XCM when I am talking here M into 0 plus this is nothing but here we will be getting as 2M into this is located at R plus R, this is 2R by here we will be getting as total mass will be, this is mass will be M only, and here we will be getting as 2M we will be getting. So here 2 gets cancelled. So here this is R will be getting, this is mass will be M into 2R, this 2 gets cancelled, mm gets cancelled, here we will be getting as R will be getting. So here final center of mass will be getting as after removal of the C mass R comma 0 will be getting. Then if you are talking about the shift of center of mass, when you are talking, here you can take as R comma R by root 3 minus here you can take as R comma 0 when you are talking, here R minus R it will be 0 and here we will be getting as only R by root 3 will be getting. So R by root 3 is the correct answer. Here this one if you are talking here after removal you can take students, here I am just giving, here it is somewhat clearly. This is here M1 into M into 0 plus here you can take the second mass also will be M, and this will be located at 2R distance, 2R by total mass you can take as 2M you can take. So this 2M gets cancelled, so that will be getting as R will be getting. So this is a R by root 3 is the correct answer. Now let us discuss about the continuous distribution of the mass related question, students. Here the first question says, if 3 rods of same mass are placed at the shown in figure, and here the coordinates of center of mass of the system they are asking. Now here you can take students, here it's going to be lying 3 rods of same mass it's given. Now here this is one rod you can take, and here it is one rod, and this is the third rod you can take, and here it is lying on x-axis a comma 0, and here 0 comma a is given, and here you can take this coordinates when you are talking, and here this side is a and this side will be a in the sense here this center of mass here it will be located at somewhere else. This is along x-axis and y-axis you can take, and here when you are talking this portion I am going to be enlarging like this rod, and it's making an angle here you can take as 45 degrees. Why? Because both the sides will be same will be getting, and if you are taking this is 45 degrees, and here you can take as this side length is given as a is given, and here this total side length is a, and the center of mass here it will be located at a by 2 distance. Now this is here you can take as a by 2. A by 2 when you are talking opposite side will be getting as a by 2 sine 45 degrees. Adjacent side you can take as a by 2 cos 45 degrees, which is nothing but here a by 2 into 1 by cos 45 will be getting as root 2 will be getting. So here you can get it as this is cos 45 1 by 2, and here it will be a by 2. Sorry students, here you can get it as one thing, here it will be, sorry, right, this is here actually this side is a and this side is a in the sense total you will be getting as root 2a will be getting, and here this center of mass in the sense here you can take as this will be a by root 2 you can take a by root 2. Now this is a by root 2 which is making an angle 45 degrees. Then this component will be getting as a by root 2 sine 45. So which is nothing but 1 sine by 45 in the sense, so a by root 2 into 1 by root 2 you can take, which is nothing but a by 2 will be getting. And here also 1 by root 2 into 1 by root 2 will be getting as a by 2 will be getting. So here for the third rod which is inclined on the plane, here will be getting as a by 2 and a by 2 are the coordinates. Here at this point, here this is a point you can take. The center of mass will be at a by 2 comma a by 2. So now let us take the coordinates will be so first mass coordinates here will be taken as a comma 0. Second mass coordinates you are taken as 0 comma a, and the third mass coordinates you can take as a by 2 comma a by 2 you can take. Now here it's lying in the plane in the sense, here we can talk about the xy coordinates you can talk. Along x-axis in the sense, here we can take as m1 x1 plus m2 x2 plus, here we can take as m3 x3 by, here we will be getting as m1 plus m2 plus m3 you can take. Mass here it is given as m is given, each are right into a, plus here we can take as m into 0 plus, here we can take as m into x3 in the sense, here we can take as a by 2 you can take. Let us take this is x1 y1 and here it is x2 y2 and this is x3 y3 you can take. By total mass you can take as 3m you can take 3m. So when you are simplifying this values, here xm value will be getting as, so in numerator here it will be 0 and here ma plus ma by 2 will be getting as 3 into ma by 2 will be getting, in denominator 3m will be getting, 3m gets cancelled, here will be getting as, this is x1 will be a and here m2 x2 x3 by 3m will be getting. So here will be getting, this is a by 2 will be getting. And at the same way here we can talk about YCM also, YCM which will be equal to m1 y1 plus m2 y2 plus, here you can take as m3 y3 by, here you can take as m1 plus m2 plus m3 you can take, which is nothing but here you can get it as m1 you can take as m you can take into y1 value you can take as 0 plus m2 you can take as m you can take, y2 value will be, it is a you can take plus m3 you can take as m you can take, and here it will be a by 2 by, here we will be getting as m1 plus m2 plus m3, that is 3m you can take. So ma plus ma by 2 in the sense, here ma you are taking common, 1 plus 1 by 2 will be getting as 3 ma by 2 by, here we will be getting as 3m will be getting, and here 3m gets cancelled, here we will be getting as a by 2 will be getting. So here a by 2 and a by 2 is the correct answer. Now let us see the next question, students. So the next question says here two uniform rods A and B of length is given as 5 meter and 3 meter are placed end to end, and here if their linear densities are 3 kg per meter and here 2 kg per meter is given, and here you can take the position of their center of mass from their interface they are asking. So here first let us calculate two uniform rods is given, students. Here the linear mass density in the sense, here we can take as ρ1 which will be equal to its mass per unit length you can take m1 by L1 you can take. That doesn't mean m1 value will be getting as, initial linear mass density is given as 3 kg, its length is given as 5 meter. So m1 equal to, here you can take as, this is 3 into 5 you can take, which is nothing but 15 kg will be getting, and the second linear mass density is given as 2 kg per meter and m2 by L2 you can take. So m2 which will be equal to, you can get it as ρ2 into L2, that is 2 into you can take as 3 you can take, which is nothing but 6 kg will be getting. Now let us take, students, here two rods is given, uniform rods. One rod length is given as, it's a 5 meter it's given. One more rod it's given as 3 meter it's given. This is a 3 meter rod it's given. And here you can detect this is 5 meter, and here you can detect this is 3 meter is the length rod. Now we calculated this mass will be, first mass will be 15 kg, and here it's given as 15 kg, and here the second one it's given as 6 kg we calculated. Now here let us calculate the position of their center of mass from their interface. Interface doesn't mean here where they are going to be attaching, that's an interface we can take. Now let us calculate about that point, we just calculate the center of mass. So here XCM, which you can take as XCM, which will be equal to M1 X1 plus, here you can take as M2 X2 by, here you can take as M1 plus M2 you can take. So first mass rod it's going as 15 kg, it's going to be X1. X1 in the sense, here you can take students, here the center of mass where it will be located, and this is 5 meters rod in the sense, here its center of mass will be at the center, so here we will be getting as 2.5 centimeter distance. So here it will be at 2.5 centimeter distance, here it is going to be located, center of mass, this center of mass. And this center of mass in the sense, here we will be getting as at 3 meter is the length, means here you can take as it is at 1.5 meter distance. So here you can take 15 into this rod will be located to the interface left side, so that here you can take as minus 15 into, you can take as 2.5 you can take plus, and mass M2 is you are getting as 6 kg, 6 into the center of mass will be located at 1.5 you can take by, you can take as M1 plus M2. So 15 plus 6 will be getting as 21 will be getting. So when you are simplifying this value, here we will be getting as minus 37.5 plus, here we will be getting as 9 by, here you can take as 21 you can take. So when you are simplifying this one, here we will be getting as 19 by, here 14 you will be getting, 19 by 14 you will be getting on the side of heavier end you can get. So it's a positive value will be getting, positive value in the sense, here will be getting as on the side of the heavier end will be getting, on the side of the heavier rod. Sorry, this is minus value will be getting, minus value here, minus 37.5 plus 9, this is minus 19 by 14 will be getting. So here this value will be a minus value you are getting in the sense towards left side, here it will be located. That's an answer. Let us see the next question, students. 3 identical rods of each length is given as L and mass M. Here they are going to be adjoining like U-shaped one. The distance of the center of mass of the combined system from the corner O they are asking. So from the corner O in the sense, here these 3 are the identical rods is given, students. So to this rod here, to this rod the center of mass will be located at L by 2 comma 0, it's lying on x-axis. So for this rod here you are taken this, the center of mass will be at 0 comma L by 2 distance, and here this rod when you are talking along x-axis, here it will be length will be L, and along y-axis in the sense the center of mass will be located at the center, so here you can take as L by 2 distance. So from the corner O they are asking its distance of center of mass. So now first we can calculate, it's lying in xy plane in the sense, here XCM you can talk, students, here M1 X1, so this coordinates you can take as x1 y1, and here you can take as this is, or else here this is x1 y1 you can take, and this is x2 y2 you can take, and here this will be x3 y3 you can take coordinates. So here you can take as m into 0 plus m1 x1 plus m2 x2 plus, here you can get it as m3 x3 by, here we will be getting as m1 plus m2 plus m3, that's nothing but 3m you can take. This will get cancelled, here we will be getting as, so 3 by 2 ml will be getting, by here you can get it as 3m, so 3m gets cancelled, here we will be getting as L by 2 will be getting. The same way YCM when I am talking here, so m1 y1, it's L by 2 plus m into m2 y2, it will be 0, plus m3 y3. Y3 in the sense here will be getting as L by 2 by here you can take as total mass will be 3m will be getting. So here together m into L by 2 plus m into L by 2, that is ml will be getting. It's an ml by, here you can take as 3m, you can take mm gets cancelled, here will be getting as L by 3 you are getting. Now here xcm value, ycm value you are getting, and now here we just calculate the distance of their center of mass. That's nothing but here RCM you are taking distance of location of center of mass. XCM and YCM values when you are taking, here both will be perpendicular. Then here you can take XCM whole square plus here you can take as YCM whole square, you can take under root, which is nothing but here will be getting as L square by 4 plus L square by 9 you can take under root, which is nothing but L you are taking common, 9 plus 4 13 will be getting 13 L square by 36 will be getting under root. So here this is RCM which will be equal to L you can take outside, it's root 13 by 6 will be getting. So root 13 L by 6 is the correct answer. Let us take the next question, students. Two uniform rods A and B of same diameter having their lengths are given as 2 meter and 3 meter and their mass per unit kg is given as 4 kg per meter. So initial linear mass density, here length is given as L1 2 meter and here it's a linear mass density means rho 1 you can take, which is nothing but m1 by L1. So here this value is given as 4 kg per meter, which will be equal to 4, which will be equal to m1 we don't know, here L1 value you can take as 2, that's nothing but m1 equals you can take as 8 you can take mass value. L2 it's given as here 3 meters you can take, and here rho 2 you can take as m2 by L2. It's a linear mass density is given as, second one is given as 6 kg per meter, 6 which will be equal to you can take as m2 by L2 you can take as 3 meters is given. So here second mass value will be getting as 18 kg will be 360 will be getting as 18 kg you are getting. End to end here you are going to placing the position of center of mass. So here you can take two rods is given, one rod length is given as 2 meter and here one more rod is given as 3 meters is given. This is 3 meter it's given. So the position of center of mass of the combined rod from the free end of A. So this is your origin, students. So here this is A you can take and this will be the B rod you can take. From the free end they are asking. So this center of mass where it will be located in the sense, center of mass for this rod located at the center, this is at 1 meter distance, and here this center of mass will be located at 1.5 meter distance from this interface. Now you can take about this point in the sense, here B will be located 1, 1 plus 1 will be getting as 2, 2 plus 1.5 you can take, nearly 3.5 will be getting. So here center of mass of the B will be getting as at 3.5 meter distance. Here if you remember, students, here too we need to calculate this center of mass, and this center of mass will be located at this point. Now let us take here XCM value. If I am taking the sense here m1 x1 plus m2 x2 by, here you can take as m1 plus m2 you can take. So m1 it's given as 8 kg into x1 in the sense, here you can take as its coordinate will be 1 plus second mass will be 18 into x2 value you can take as 3.5 by you can take as 18 plus 8 will be getting as 26. So together you are simplifying means XCM value will be getting us nearly 71.71 by 26 will be getting. So here it's meter, it's length 2m it's given, students. Here you can take as, in all the cases m you can take. Here you can take as m and here you can take as m, like that. Now let us see the next question. If the linear mass density of the rod is given as 3 meter, it varies lambda equals, it's given as 2 plus x, then the position of center of gravity of the rod they are asking. So So here one linear rod is given, students. This linear mass density is given, lambda equals to 2 plus x is given. Here you can take small elemental length, you can take, student, this is dx you can take, and here it is about a distance x you can take from the origin. Linear mass density formula for small elemental length you can take as lambda equals, you can take as dm by dl you can take. Then here for uniformly distributed masses, here the position of center of mass, the formula will be writing as xm, which will be equal to x into dm by integral x into dm by, you can take as integral dm you can take. So here it's going to be lying here, the length you can take, it's a 3 meters is given. Here you can take that this is it, 3 meters rod is given. So limits you have to take as 0 to 3 you can take, and here also 0 to 3 you can take. So here you can take lambda, already it's given 2 plus x integral 0 to 3, which will be equal to, this is x in the sense, here you can take as dm in the sense, here lambda into dx you can take. So here we will be getting as lambda into x into dx you can take, instead of dm you can write it as lambda into dx you can take, already x will be there, by integral 0 to 3 dm in the sense, here you can write as lambda into dx you can take. Now here xm, which is nothing but lambda, already you know, students, here we will be writing as 2 plus x into x into dx you can take, but in the limits you can take as 0 to 3 by, here you can take as integral 0 to 3 you can take as 2 plus x into dx you can take. So when you are multiplying, here you can take as 2x plus x square into dx. So between the limits you can take as 0 to 3 you can take, by, here you can get it as 0 to 3, 2 plus x into dx you can take. So here you just substitute, students, xm, which will be equal to 2 into x dx is nothing but 2 into integral x dx is nothing but x square by 2 plus integral x square dx will be x cube by 3, but in the limits you can take as 0 to 3 you can take, by, here you can take as 2 into integral dx is 2x will be writing, integral x dx is nothing but x square by 2 you can take, but in the limits 0 to 3 you can take. So this 2 gets cancelled, and here you have to substitute, and you are putting these values 3 square plus this is 3 cube, 27 by 3, by, here you can take as 2 3s are 6 plus 3 square, you will be getting as 9 by 2, 3 9s are, so here 9 plus 9 will be getting as 18, so 18 by, here you can take as 2 6 are 12, 12 plus 9 will be 21 by 2, here it will come to the numerator 26, and here you can take as nearly, this is 36 by 21, 370. So here xm will be located at 12 by 7 centimeter. So 12 by 7 meter is the correct answer, students.